All right, so our next topic is TBEST model characteristics. So we would just want to talk a little bit about what the model is designed to do in terms of ridership estimation, and primarily some of its components and how it uses data, and then the specific types of data to calculate ridership or estimate ridership. So basically, it's designed to capture walk access to and from transit, capture accessibility via the transit network. So that means that if you think about it in terms of productions and attractions, what's around a stop is the source in terms of demand at the stop, how many people are there, their demographics. And then they have attractions through the network. So TBEST will look all the way through the network and where they can get to from that stop within a certain amount of time, and then compile all the destinations as attractions. And then the further away you go from that subject stop, the less impact that it has on the subject stops in terms of attractions. So it allows for special generators. We've talked about that, including park and ride spaces. It responds to resident demographic characteristics. So not only is just total population, but it is the demographics of that stop as well. It responds to parcel level trip attraction and production based on IT trip generation rates. So we mentioned that a little bit earlier with we showed the spreadsheet that has the trip generation rates in it for each parcel type. So those trip generation rates get applied to every parcel, and then that gets input into the model as productions and attractions it sees in terms of, at the subject stop or destination stops. It's designed for fixed route transit. So if you're dealing with mobility on demand, it does not estimate ridership for mobility on demand. So just keep that in mind. Other characteristics, it's a direct demand model. It's designed to be applied in the short term, or 0 to 10 years. And what that direct demand means is that it doesn't take into account any other mode other than transit. It doesn't take into account, cars, vehicles, bicycles, basically any other kind of mode of transportation. It doesn't really take that into account, right? So it's just a transit model. And the reason it's 0 to 10 years is because it assumes that most of those other modes are static for the most part within that time frame. They're not going to change too much. Now, in your out years, 20, 30 years, they can change a lot. So in the short term, we can make some assumptions about that a lot of our other modes aren't going to just change that much in the very near term. All right, some response to key transit demand and service characteristics, route alignments, headway changes, span changes, fares, new stops and routes, and growth and transferability in the network, walk markets to stop destination markets. And as I mentioned, it's stop level estimation for 6 distinct TBEST time periods. That's all the 4 weekday periods, Saturday and Sunday. And it does estimate at the stop level both direct and transfer boardings. So in the end, when you run a TBEST model, you're actually running 12 models. You're running a direct boardings model for 6 time periods, and you're running a transfer boardings model for 6 time periods. So an approach to modeling, what can be modeled, operating strategies as a category, schedule changes, alignment changes, system changes in terms of system redistribution and network structure, your fare policy. So any kind of really total change or subtle changes that you want to make in your network, most of those can be modeled and would be sensitive in the TBEST model. The approach to modeling, again, with the TBEST Land Use 5, so it integrates the parcel land use data into the TBEST model stream, and it uses the activity levels at each parcel measured in person trips and their geographic distribution. So over on the right, you have different stops. So basically, if you have a stop right here in the middle or here in the middle, this is the buffer. It could be a quarter of a mile for the model that's seeing the parcels, right, that are in its buffer. And so Basically, it's going to calculate all the person trips or activity levels at every stop and assign that to the stop, right? So when it runs the model, that's what it does. Now, the further the way away a parcel is from the stop, the less impact it has in terms of walk access. There is a decay method that happens here too, so that the further away a parcel is from the subject stop, it doesn't have as much impact just because it's further away. And of course, you use the trip generation rates to measure the activity levels. We showed you the spreadsheet, which is actually editable. If you change the values inside of that spreadsheet, it would then reflect in the model if you ran it that way. So just keep that in mind that it is editable and you could make edits to it. All right, so one other characteristic we have that's kind of unique for TBEST is that there is a BRT sensitivity. So if you define a route as a BRT, then you have the added ability to define route characteristic scoring for it because not every BRT is made the same. They're all varying in their implementation, whether it's the vehicles, the stations, the travelways, or the branding or marketing. Each one of those characteristics plays a role in ridership demand and forecasting. So basically, this scoring mechanism where you're able to input a value from 0 to 5 for different characteristics of your implementation of a BRT, it came out of a research project from Qatar years ago where they looked at BRTs from all over, not just in the US, but in other countries as well, and came up with the scoring system to adjust ridership based on the implementation levels of the different characteristics. So basically, if you have a BRT, you can use this scoring methodology to increase the ridership, meaning like adjust it upward based on what you have implemented relative to it, right? So it's a great way to test a BRT in different levels of implementation and is very responsive to how you would implement it in terms of the different characteristics. In the user guide, we have for every characteristic, we have a detailed guide on how you would approach the scoring. So if you are going to go through that process, there is some valuable information in the user guide to help guide you through it. Okay, just a note on FDA stops model versus TBEST. Of course, TBEST is not approved by FDA for new starts or small starts funding. That is the general purpose of the FDA stops model. So it's not approved for that. But basically, you can work alongside stops, where you can actually have two models, and you can run the stops model along with TBEST to get, two different ridership estimations that, maybe it's not for new starts or small starts, but if you're just evaluating your models and trying to gauge your, put some additional information in, it's pretty good practice to run maybe both of them. TBEST is primarily a walk access mode of arrival, which I think the stops model uses skims and different things like that for coming up with accessibility through the overall network to different destinations, not just through walk access. TBEST does not fully represent drive access to transit or other access modes, which is true. However, we do have the ability to override stop level markets. So I don't know if you remember when we were looking at the stops panel early on, you saw that every stop has a socioeconomic value that was assigned to it, and it was assigned to it through the model run. Now, what's cool about that is you can edit those values to be what you want them to be. So if, let's say that an Amazon facility is planned to be at one of your stops, and currently all of your SE data and every data source you have does not have an Amazon facility there, you can override what's at that stop to say there's 0 employment at that stop right now, but we know there's going to be 5,000 employees that come there, in a year. So that will, very much change your ridership. So So basically, that's what this kind of stop level override allows you to do on a stop by stop basis. You can change those values, and then TBEST, the model, will see that you've changed it and pull your data in at the stop level rather than recalculating it from the census, et cetera, right? So that is what is unique. One of the unique things about TBEST, where you can override local population and employment calculations that might be more general to be something very specific. All right. TBEST performs the weekday and Saturday and Sunday ridership forecasting and allows for annualizing results. I'm not sure that STOPS does that. And TBEST does not consider traffic congestion. So that is also true. So what I would say, though, is TBEST does have a network editor, where I don't believe that STOPS has a network editor, meaning that we can actually create a GTFS in TBEST, meaning using the network editor, and export it out as a GTFS. And then that could be used as an input to the STOPS model potentially. So just as a note that, there are things like that you can do to kind of, if you have your TBEST available, you can do your network editing, export to GTFS, use that potentially in as a future year for your STOPS model. So I'm not really a STOPS model expert. I have some familiarity with it, but just that's some of the ideas and knowledge that I have of it. So certainly there is probably more detail that can be expressed. Okay. So, all right. So once we get to a TBEST model run, we're ready to run it. It really is set up for you. There's very little that you need to do to actually kind of configure a model run. Most of the options are by default. And if you don't change anything with the TBEST land use model 5.0, there really isn't anything to consider, because whenever you run the model, it actually tracks, TBEST does, your edits. So it knows where you've made edits. And if you need to run full market, socioeconomic market capture will be set to true, apply capacity constraints. All these are just variables that are options that generally remain the same. In very few circumstances would you ever change them. So essentially, you go to run the model. It will tell you the time periods that you want to run for. If you've edited those time periods, then it will show up as checked. If you have not edited them, they will be unchecked. So essentially, you don't need a model run. And you can always hit, just when you're ready, hit run model, and you're ready to go. Okay. So we'll just stay here. I think this is a very quick, we're just going to run through and execute a model run. So very simple. And so what I'm going to do is just close my Gatorville Fall 2024 scenario. I've already saved it, so it's all ready. We've made our changes to it. And so I'm just going to pin my Explorer, so it's back now as my panel. It's not an auto hide. And I'm going to right click on Fall 2024 and select Ridership Estimation Model. So we have our Gatorville Transit System. Our Fall 2024 is select the scenario to model. All of our time periods will be run through the Ridership Estimation Model, and we will just use the default model run options and run from there. Okay, hit Run Model and hit Yes. All right, so we'll let that run. I will move this over and go right back to the slides. Any questions?